solve, the absolute value of 2h plus 12 is equal to 7h minus 3. Whenever we're trying to solve absolute value equations, we want to make sure that the absolute value is alone and it equals a distance that you can travel away from 0. So here we can see the absolute value is alone, and the distance they would like us to travel away from 0 is 7h minus 3. Well, there are two directions that we could travel from 0, to the left and to the right. So we're going to do each of those directions and solve for h accordingly. So let's get started by solving for going to the left. And remember, going to the left, that means you're working with negative numbers on the number line. So we have negative 1 times our starting point of 2h plus 12 equals our distance of 7h minus 3. Again, we want to undo this to solve for h. So our first step should be undoing the multiplication. So we would divide by negative 1. That would leave us with 2h plus 12 is equal to negative 7h plus 3. At this point, again, we want to put the variables on one side and the constants on the other. So we want to combine our h's and our constants. So here, let's work on combining the h's by adding 7h to each side of our equation, which would result in 9h plus 12 is equal to 3. So the h's are on one side of the equation. Let's put the constants on one side. So let's subtract 12 from each side of our equation, which would result in 9h equals negative 9. In order to get h alone, since it's being multiplied by 9, we're going to undo that by dividing each side of the equation by 9. So h would equal negative 1. Well, that's only if we travel to the left on our number line, but we have another direction to travel as well. We can travel to the right. We're going to have to solve for traveling to the right, but we also want to check our solutions as we go along. So let's start by checking our negative 1 first by substituting it back into our equation and working it out according to our order of operations. So we got some multiplying to do. So we have the absolute value of 2 plus 12 equals 7 minus 3. So we have some simplifying to do. Negative 2 plus 12, that would be 10, and 7 minus 3 would be 4. And so the absolute value of 10, so you have to ask yourself how many units away from 0 is 10 on the number line. That's 10. And does 10 give you a distance of 4? It does not. Well, since this is a false statement, that reminds us that this solution, h equals negative 1, cannot be used. It's an extraneous solution, so we have to eliminate it from our answer set. So now that we've done our left-hand side, let's go and do what we talked about before, traveling to the right. So when we go to the right on our number line, we usually denote it by saying 1 times our starting point equals our distance. And to undo that multiplication, we could divide each side of our equation by 1. Again, we find ourselves needing to combine our like terms, our variables on one side, our constants on the other. So here we could subtract 2h from each side of our equation, which would result in 12 equals 5h minus 3. Again, we have to combine our like terms, so the constants need to go together. So let's add 3 to each side of the equation to undo that subtraction, which means we have now 15 equals 5h. Well, it's 5 times h. To undo that, we could divide each side by 5, which results in h equaling 3. So again, here we need to check and make sure that this value for h satisfies the requirements for the equation. So we're going to do our check. So we're going to substitute 3 into the original equation. We've got some multiplying to do. So we got 6 plus 12 inside our absolute value equals 21 minus 3. Well, 6 and 12, that would be 18, and 21 minus 3, we can simplify that also to 18. We know the absolute value of 18, that means it's 18 units away from 0. So the question is, do our distances match? And they do. So we have one solution for our equation, h equals 3.